Hello pilots, this is Christian, also known as First JG27 Nemesis from Germany, and what I'd like to show you today is the effect of the thick Armorglass windscreen of the Focke Wulf Fw190 and which dramatic effect it has on the pilot's view. And what I've prepared for you is a small drawing showing what we're talking about. It's the Focke Wulf Fw190 windscreen, this thing here, mounted in this type of frame. It's actually here, this thing. We're talking about this little piece of glass. Okay? One piece of paper, the size of the original Focke Wulf Fw190 windscreen. Test sample of armored glass, which is about the same width, but a little shorter from the length and a little thicker. It's 1.5 times the thickness of the original glass. And last but not least, an empty frame of carton. It's exactly the same size as the test glass, just to see how the areas that we don't like to see in this simulation look like, and just to see it's exactly fitting over the glass. Now we see the empty frame, and I want you to just look at the frame itself, see how thick it is when it's filled with air. And what we have here is the frame of the very same size, just filled with glass. So I've put this piece of armor glass in a 25-degree angle. The first thing you'll notice is how steep this 25-degree angle really is. Whereas other aircraft have almost vertical windscreens, this is really steeply sloped. I want to show this, that it's exactly 25 degrees. And what effect this has is a strong refraction of the line of sight of the pilot. When we look at the 3D engines modeled in IL-2 Sturmovik from 2002, this area here, the front frame of the windscreen, was limiting our view. It became the not glorious name Oleg bar. And this was bullshit because it is not seen in real life where it is, but very much lower if seen at all. So to make this even more obvious, I have these two, which are roughly the same height as the windscreen front, and I put them in front of there, so it really blocks the view where the frame is. And now let's see this from the rear, from the pilot's perspective. And what we're seeing is this massive area that should be blocked is clear. So when you look at my balcony, there's a metal bar going horizontally, so it's just perfect for demonstrating this. I could put my head up here and still not see it. Now I would see it, but my head would have gone through the roof of the canopy, so it's impossible. You can't see it. So you're looking at this bar, you see nothing. So when I'm not behind air, but I am behind armored glass, my vision is this. I don't have to lift my head, I can sit comfortably in the cockpit and see. It's not a problem at all to see it. And the same also applies to the sides of the frame. And of course, to simulate a view that is close to the real thing, you cannot simply put the blueprint in your 3D model and say you've done everything correct, because you have not. You would have this bar right in your face. So it's not only blocking the aiming, it's also blocking the view from the pilot, not only to the front and down, but also to the sides. And this is a massive impairment, a massive deterioration of pilot's view. And this is not at all acceptable in a simulation that calls itself realistic. What I've also done is putting a straight wire to the upper left corner of the glass, and it's aligned straight, so we have an idea where this upper left corner of the glass, which is optically limiting our field of view, where it really is. But if we go into the pilot's perspective back again, you see the side frames, which are quite thick, appear small. And when you look up here, you see where the wire is, and this is the geometrically correct position of the frame, of the upper left frame, which usually would limit our view, but it doesn't. You see, it's really down there, not up here. And this is also pretty much impairing our vision, is harming the view that we have out of the Focke Wulf Fw190 cockpit, and this is simply not acceptable. What has to be done in order to make a correct pilot's perspective in All-2 Sturmovik Battle of Stalingrad or other sims? We have to make those side frames, these areas, much thinner. We have to lower the bar in front of here. This area, what I have put here in front, we have to make this maybe the size of this. And then we have this lower end, which I showed you from the inside, that really does limit our view. But it's much lower, and therefore the vision is much better. Of course, what you would see in a real aircraft in front of the lower end of the windscreen is not clear air, but the top of the cowling. So I put this piece of carton in front to mimic the top of the cowling. It's about horizontal, and this should give us the direction of the nose of the Focke Wulf Fw190. And of course, when we go back into pilot's position, we clearly see the top of the cowling and not any bar. I decided to make a side-by-side comparison of the frames, identical frames, one frame filled with glass and one frame carton filled with air. It's so ridiculous. Compare this to this back there. You know, this line, this little thing, equals to this. Look at the house across the street. The windows, the white area below the windows, and the green hedge on the bottom, and how much of it is visible with and without glass. And at the same time pay attention to the roof level of the house and compare it with air versus glass. Here, in my arm's length, I have something blocking the view entirely. And the position where it is seen is changed dramatically. But on the other hand, when I look to the horizon, see the horizon. Once you have the horizon, it simply doesn't matter anyhow. If that tree 2 miles away is 1.5 inches lower or not, it simply makes no difference. So finally, I want to measure the amount of elevation of the line of sight of the pilot by the glass, and I've fixed this straight piece of wire with the external lower field of view limit. The vertical elevation of this wire is about a little less than 7 centimeters. It's about 69 millimeters high, and there you go. You have the line of sight limit. Of course, it depends on which elevation the pilot has his head. When it has its head lower, it's less effective. When he has his head positioned higher, it gets to a point where it simply doesn't matter anyhow. So what is 69 minus 13? 56. And if we divide 56 by 1.5, it's even more than I expected. But why this is 37 millimeters? It's explainable, because the 25-degree angle is correct when we're talking about looking straight. When you look to the lower view limit, the slope angle really gets even lower because you're looking down. And thus the angle between your line of sight and the glass changes. Thanks for watching this video. I hope you enjoyed it, and let's hope the developers can utilize it. My special thanks goes to engineer Sir Don Hansen for providing me photos and metrical information on the real Focke Wulf Fw190 windscreen measurements. Thanks a lot, Don.